Hi, so my name is Dr. Nick Longridge. I'm a paleontologist and evolutionary biologist. And today I'm going to talk about Tyrannosaurs. The title of today's talk is A New Tyrant Dinosaur from Northern Mexico and a Southern Tribe of Tyrant Dinosaurs. So this is kind of a cool discovery. One of the questions I often get is, did Tyrannosaurus live everywhere? And the answer is no. No, it didn't. Part of the reason has to do with the arrangement of the continents. So if we go back and look at the map of the world at the very end of the Cretaceous period, it looks quite different than it does today. So what we have here is a period of continental fragmentation. The supercontinent Pangaea has been breaking up for tens of millions of years. All the continents are separated. They haven't started to reconnect yet as they have today. And then sea levels are really high. High levels of volcanic activity have pushed the oceans up onto the continental shelves. And as a result, we have a series of island continents. So everything's kind of isolated. And T-Rex evolves in the western interior, in western North America. And because of these seaways, it can't get to eastern North America or South America or Africa or Europe, et cetera, et cetera. So just the configuration of the continents means these things can't easily have global distributions. Even taking that into account, though, we still have this rather interesting problem where within individual land masses, things are still not very widely distributed. So for example, at the very end of the Campanian, we have Gorgosaurus, a tyrannosaur that's found up in Alberta in Canada, and we have a different species called Bistahieversor that's part of a different subgroup of tyrannosaurs found in New Mexico. So even within the western interior, you have different tyrannosaurs in different places. And at least when Tyrannosaurus initially appears around about the Campanian-Maastrichtian boundary, it's only found in the south. We don't actually find it up north in Canada, and only up at the very end of the Cretaceous period, right before the dinosaur extinction, does T-Rex become widespread in western North America. And even then, it never seems to get all the way over into Mongolia. So we're seeing this interesting pattern where dinosaurs actually have really restricted distributions. So why is this interesting, and why is this surprising? Well, it's surprising because this is not how modern large mammals work today. So typically big animals have big geographic ranges. They can range quite widely. They have a relatively low cost of transport with these great big long legs. So African elephants are, for example, widespread across basically all of Africa. So they have this very large geographic range, and other large-bodied species tend to be similar. And this is particularly true of large-bodied carnivores. They tend to have very large ranges. So today, lions are restricted to Africa, although they're widespread throughout Africa. Historically, they went all through sub-Saharan Africa, into North Africa, the Middle East, Southern Europe, all the way into India. So they're very widespread. Wolves had an extremely wide range, going from Europe all the way into India and Asia into North America. And so we had these carnivores that were very widespread, and even fairly small animals were widespread. So red foxes, for example, were widespread throughout Eurasia and into North America. So dinosaurs seem to be doing something different. It's a little bit puzzling, it's perplexing and not expected that you have an animal that's both very large, it should have a low cost of transport and be able to disperse quite readily. It's a predator, it should be able to eat almost anything it wants. Meat is basically meat, so it's not like it goes to a different part of the world and it can't eat the dinosaurs there. You know, they taste basically the same wherever they are. So it should be quite unrestricted, and yet these things have these very restricted distributions. Dinosaurs seem to have small geographic ranges, at least in the late Cretaceous in western North America. And what does this mean? Well, from a practical standpoint, it means that all you have to do to find a new dinosaur is move about 1,000 miles into a new formation, and suddenly you start seeing new things. So in recent years, I've been working in Mexico, and new things are starting to come out there. There's just a lot less known about Mexican dinosaurs. There's a fair amount of dinosaur bones out there in the ground. They have not been worked for very long or as extensively as they have in, say, Alberta in Canada or Montana, the Dakotas, Wyoming. It's just not as well sampled, and yet there seem to be a lot of new things down there. So things like velafrons, the duckbill, Tlatlalophus, this animal we recently described called Coahuilasaurus. There's a couple of undescribed ceratopsians in this fauna. So there's just a lot we don't know about Mexico. And, you know, almost anything you pull out of the ground has a very high chance of being new. That is also true of almost anything you pull out of the museum collections that's reasonably complete has a pretty high chance of being new. So I got really interested when I went to Saltillo in Coahuila, recently and pulled open this drawer, and there was a Tyrannosaur skeleton there from the latest Campanian Cerro del Pueblo formation. This is a fragmentary skeleton, emphasis on fragmentary. It's not just fragmentary in the sense that we don't have a lot of different bones. It's fragmentary in the sense that these bones are broken up. It looks like a pile of rubble. It looks, you look at this thing and it looks like it'd be better used for gravel than for, describing a new dinosaur species. But these pieces do go together, and a lot of these pieces, if you look at them closely, they actually tell you a lot. So again, the material's not great in terms of the preservation. It's been probably out on the surface of the desert for hundreds or thousands of years. It's covered in this stuff called desert varnish. It's these minerals that form on surfaces in the desert when they're exposed for a long period of time. And it's very broken up. And so because of this, it kind of sat in collections unstudied. Typically, if someone has a really beautiful, perfectly preserved Tyrannosaur skeleton, somebody's going to come along and work on it. So if you want to find something that people have neglected, it's often neglected for a reason. And so yeah, this is challenging to work with, but hey, challenges are fun. That's part of why I get into science. If it was easy, what would be the point? And again, that's kind of where the opportunities are, is going to challenging places. Maybe fools rush in where angels fear to tread, and so very fragmentary skeletons. But it raised this question: we have this Tyrannosaur skeleton. What is this animal? So first of all, it is in fact a Tyrannosaur. We have this relatively short forelimb and a much longer hind limb. We have here the humerus, the upper arm bone. We have the femur, the lower, the upper leg bone. And you can see, well, they're not quite to scale, but you can see just how much longer the femur is than the humerus. So this is typical Tyrannosaur, long legs, very, very short, stumpy arms. What is quite interesting, though, is that the hind limb bones are quite gracile. So this is not something closer to Tyrannosaurus. Tyrannosaurus is a very chunky animal. It's massively built. This is quite lanky, so it's a much more primitive type of Tyrannosaur than Tyrannosaurus is. However, to really figure out what this animal is, limb bones aren't particularly useful. What's really useful are skull bones. Skull bones are very complicated. They have all these elaborate sutures and contacts with other skull bones, and one skull bone might contact half a dozen other skull bones. It has the contacts are all different, and there's a lot of just character information on these skull bones. So I started sorting through this thing, and then kind of pulled something sort of interesting out of the drawers. And that was this bone, and it doesn't look like much. It might not even obviously be a bone. It just kind of looks like a discolored rock. But when I saw this, it's like, oh yeah, this is the good stuff. This is the frontal bone. So the frontal bone is part of the skull. It basically goes over the eye here. It forms part of the orbit and part of the brain case. And it's kind of one of the key bones of the skull. It kind of, the brain case, everything, jaws and all the other stuff attached to that. So it's a very, very complex piece of anatomy. You can tell a heck of a lot about a dinosaur from the frontal bone alone. So this is what we have. There's this frontal bone. Found another piece of kind of heavily broken up skull bone that kind of clicks onto it and makes part of the other frontal. And we can get a reasonable picture of what the skull looks like here. And you can see there's these sutures here, sutures to the other frontal. There's kind of a keel on top of it where the jaw muscles would attach. There's contacts to the lacrimal, contacts to the postorbital, contacts for, I believe, the orbitous sphenoid there, all these different contacts. So again, there's a lot of character information here. It can tell you not just that you have a Tyrannosaurid, but what subfamily you have, what tribe you have, what genus you have, and sometimes what species you have. So what is this animal exactly? Well, one of the interesting things I noted was the shape of the frontal, where the frontal contacts the lacrimal. It has sort of an oblique contact. Typically, the lacrimals kind of come back and form this L-shaped contact. And here they're sort of oblique, where the frontal kind of projects forward and makes this angular contact. And so kind of on a hunch, I couldn't see this in a bunch of other things. You didn't see it in, say, Albertosaurus. You didn't see it in Tyrannosaurus. And then I went and looked at this thing, which is found a little bit earlier, but in the same general part of the world. This is Bistahieversor from New Mexico. Maybe a million years older than the Cerro del Pueblo animal. And it has this characteristic angled contact between the frontal and the lacrimal. So I'm like, aha, I think we might have something related to Bistahieversor. And then the next thing I did was look at some of the other skull bones. This little fragment here that looks like very, hardly anything, but it's kind of bilaterally symmetrical and peaked. That appears to be part of the nasal. So it seems to have quite a tall nasal, which is a fairly advanced feature. And then this little kind of, triangular piece here is a bone called the lacrimal bone, and it forms part of the orbit. And the orbit here is quite interesting because it's very, very strongly curved. That indicates rather than having a small, narrow orbit, this thing has quite a large orbit, which is unusual for Tyrannosaurids. But if you compare this animal to Bistahieversor, it has a very similar orbit. So the anterior bar of the lacrimal is very strongly curved or bowed, where it forms that kind of almost circular orbit. And then it has this little tab that's kind of in sort of the corner of the orbit, right at the kind of the corner of the eye right here. There's this little tab that kind of projects up into the orbit the other Tyrannosaurs don't have, but Bistahieversor has this and our animal has this too. So we start thinking, okay, this seems like pretty clearly the frontal is very similar, the lacrimal is very clearly similar. We have something that's closely related to Bistahieversor. And then we start kind of looking around and trying to figure out, well, what else might this thing be related to? And that took us to this animal here. And this is an animal called Labocania. And Labocania has been kind of a mystery for a long time. I think maybe it's not as much as a mystery as people think it is. It's just that nobody's really looked at it since the original paper. Not a lot has been done with it. But originally, it's just kind of it's a neglected Tyrannosaur. It's known from a frontal, parts of the maxillae, the quadrate, the ischium, parts of the hind limbs, some teeth, and it's got some Tyrannosaur-like features. The ischium is very Tyrannosaur-like. It seems to have a big triangular obturator process, which is a Coelurosaur feature, and it has this great big crescentus process where the muscle is attached on the back of the ischium, and this is typical of Tyrannosaurids. This kind of this is a dead ringer for a Tyrannosaurid ischium. And the frontals have been described as being unusually thick and lacking a supratemporal fossa. Comparisons have also been made to Abilosaurids and Carcharodontosaurids. And that kind of doesn't really make a lot of sense to me because we don't have a lot of good evidence for latest Cretaceous Abilosaurids or Carcharodontosaurids in North America. It's kind of like, well, what's the simplest explanation that fits the facts? This thing is probably just another Tyrannosaurid. But nobody really looked at this problem. So we then went and we compared our animal to Labocania. Went to the collections in Mexico City, pulled the Labocania out, sat down there, studied it, photographed it, et cetera, et cetera. And what we found was that our animal is remarkably similar to Labocania. Well, first of all, Labocania is clearly a Tyrannosaurid. The supposed absence of the supratemporal fossa, it's just kind of eroded away. It's heavily weathered there, and so the surface of the bone, the little muscle escargots, that's just been obliterated by erosion out in the desert. However, the shape of the dorsal surface, the frontal, is typical of Tyrannosaurids and would have a great big, temporal muscles, the jaw closing muscles, going up onto the top of the head, just like other Tyrannosaurs. If you look at the shape of the postorbital contact, that's very typical of Tyrannosaurids. It's got a couple facets, a deep one anteriorly and a shallower facet posteriorly. It's kind of more horizontal, typically Tyrannosaurid. If you look at the shape of the contact, the ridges on the other side that form part of the orbit, that's very typical of Tyrannosaurids. The suture between the frontals is identical to what you see in Tyrannosaurids. And, then it kind of rises up in the back to form the sagittal keel. So in every observable feature, it looks pretty characteristically Tyrannosaurid. And is it thick? Well, yeah, it's thick, but so are most big Tyrannosaurids. So things like Dynamoterror, things like Tarbosaurus have a thick frontal. So a lot of these supposedly unusual features are either misinterpretations of the anatomy, or they actually are consistent with Tyrannosaurid affinities. So this thing is in fact a Tyrannosaurid, which is sort of interesting because that makes this the first definitive Tyrannosaurid from Mexico. And then you compare our animal to it, and it's virtually identical. So very, very similar. And in particular, you've got that oblique contact between the frontal and the lacrimal bone. And so basically we started thinking our animal is probably it's either very closely related to Labocania or actually a species of Labocania. So this was kind of interesting because Labocania has been this big mystery and, I think we've kind of finally figured that out. So moving on, what else is out there that we can compare our animal to? Teratophonius is an interesting creature. The frontals are a bit different. They don't have that same oblique contact. But there are a couple of interesting features that Teratophonius shares with our animal in the postcrania. So our animal is kind of beat up here, but you can see it's got kind of this pillar that kind of comes down. This is the pubic peduncle of the ischium. It forms part of the acetabulum, part of the hip socket. And it's very rectangular in shape. And this is actually kind of atypical of Tyrannosaurids. They tend to be kind of more trapezoidal. So this rectangular shape is unusual, but it's shared with Teratophonius. Another unusual feature is that the ischium of our Tyrannosaur is very strongly bowed posteriorly. And that's also shared with Teratophonius. Curiously, the other animal that shows that is Labocania. So now it kind of looks like we have this kind of cluster of Tyrannosaurs. Our animal is similar to Bistahieversor, it's similar to Labocania, it's similar to Teratophonia. So we're kind of seeing this group of southern Tyrannosaurs that our animal is kind of right in the middle of. Moving on, this thing was published a few years ago, never really got a lot of attention. You can kind of see why it's just an isolated frontal bone, but hey, like I said, frontal bones are super informative. And we can see that this frontal bone is actually pretty similar to our animal. Again, it's got that very deep suture like you see in Labocania. The suture along the midline is a bit shallower in our animal because it's quite small. And you have this oblique contact, this sort of the frontal projects forward and sort of obliquely contacts the lacrimal. So the aguja thing, which doesn't really have a name, just being a frontal, again seems to be part of our southern group of Tyrannosaurs. Then moving on, we have this animal. This is a little frontal from the Two Medicine Formation. And this thing, I believe, was originally referred to as Dinosaurs, as a juvenile Dinosaurs. We took a look at it, and we think it's actually a little more closely related to our animal. And again, it's got that oblique contact, the frontal and lacrimal. So this may be, well, it's from the Two Medicine Formation in Montana, so it's not really southern, it's fairly far north, but it's part of this overall southern group of Tyrannosaurs. So we're starting to see, like our animal, initially it's very fragmentary, hard to make sense of, but we're starting to draw all these connections to all these other Tyrannosaurs that sort of, a lot of which nobody has really been known what to do with before. So then what we did is we did a phylogenetic analysis. So basically we take all these anatomical features, we code them up into a great big matrix, define characters, code the state of each character, and then let the computer generate an evolutionary tree. And this is what it spits out. What it spits out is a big group of mostly southern Tyrannosaurs, with the exception of that Two Medicine Formation thing. Everybody else in here is part of the southern group of Tyrannosaurs. And this is a clade that's previously been called Teratophonii, if I'm pronouncing that correctly. Yes, paleontologists also have trouble pronouncing these complex names, which is why I try to make names that are pronounceable, although I don't necessarily always succeed. So what's in this group? We have Dynamoterror, we have Teratophonius, we have the Aguja Formation taxa, we have Bistahieversor, the Two Medicine Formation Tyrannosaur, and then Labocania anomala is clustering with our animal. So we ended up making our animal a new species of Labocania. And again, what we're seeing is clade-level endemism. So we're not just seeing one species confined to the south and its relatives are up north. We're seeing an entire clade that's almost exclusively found in the south, and only one group seems to get up north briefly into Montana and never quite gets as far north as Canada, as far as we know. So we're seeing these geographic patterns that are really interesting. And then other clades show very different patterns. So at the same time, we have the Dinosaurs. These guys are up in Canada, and likewise the Albertosaurs are up in Canada, and we have this group, the Teratophonians, that are down in the southwest and in Mexico. So given that our animal turned out to be very difficult to distinguish from Labocania, given that's very closely related to it, we ended up putting it in Labocania as a distinct species, Labocania aguilloni, if I'm pronouncing that correctly. Could we be incorrect? Potentially. Could it be a distinct genus? Possibly. Could it maybe go closer to Bistahieversor? Yeah, that's possible. I mean, as with everything in paleontology, it's an hypothesis. We're dealing with fragments of bones, and even with complete skeletons, there's only so much you can do, and you tend to get things wrong. So it's our hypothesis is this is a new species of Labocania. And, hey, if you don't like that hypothesis, I have others. So we'll see what happens in future years. Hopefully we'll get more complete specimens of this animal and other Tyrannosaurs and get a better picture of what's going on here. That being said, though, I think we have made some important progress here. We've taken this kind of difficult to sort bunch of animals that a lot of, various specimens, some fragmentary, some less fragmentary that no one really knew what to do with. And it kind of said, okay, here's what we think is going on. We think there's a big southern group, and most of the things go in that group. And again, we could be wrong. Future research will show one way or the other. So what are the implications here? Tyrannosaurs show a high degree of endemism. And this isn't just species-level endemism. It's not just we have a species here and a species here. We have clade-level endemism. That is, there's major branches of the Tyrannosaur tree by the end of the Campanian are, as far as we know, exclusively found in one part of the continent or the other. Up in the north, we have Albertosaurinae and Daspletosaurinae, and these guys are found in Canada and Montana. As you get further into the south, we have Tritophonians, and you also, at the end of the Campanian or early Maastrichtian, you have Tyrannosaurus is in New Mexico and restricted to southwest for quite a while until maybe the very end of the Cretaceous when it becomes widespread. What does this mean? Well, it means we do not have a very good picture of Tyrannosaur diversity because there's a lot of places we just haven't sampled, obviously. So how do you find a dinosaur? We need to have rocks of the right age exposed at the surface. And that might not happen for a number of different reasons. It could be, for example, that erosion has destroyed the rocks as they've been exposed and weathered away millions of years ago, and you're not going to find any fossils. Or the rocks could be there, but they're under a kilometer of sediment. You're not going to find the dinosaurs. Or the rocks could be there right at the surface, but there's a bit of soil, there's some plants, there's some grass. You're never going to find those dinosaurs. You can't clear away enough grass to search a square kilometer of rock for a Tyrannosaur. So basically, we're very restricted where we can look to a handful of outcrops in the deserts and the Badlands in Western North America, and almost everything else is unknown. The jungles of the Yucatan, we don't know what's going on there. It's all limestone and it's all under jungle. What's going on in California? We don't really know. What's going on in the Pacific Northwest? We don't really know. What's going on in Alaska? Most of Alaska don't have the right types of rocks exposed. So what does this mean for understanding Tyrannosaur diversity? There is a lot left out there to find. And unfortunately, some of this stuff will never be found. Some of these dinosaurs, the last fossils were, wiped off the face of the earth millions of years ago. Others will be exposed on the surface millions of years from now. That being said, we're rapidly finding new Tyrannosaurs. And even if we'll never find them all, there's a lot more out there waiting to be discovered. And we just have to get out there and get into the desert, get into the museums, and try and figure out what it is we have. And a lot of new exciting things are going to emerge, I predict. I don't know what's going to emerge, but I'm pretty confident some interesting things are going to emerge in the next few years. So I'd just like to thank my colleagues, everybody who helped make this project possible. And thank you guys for listening, and feel free to check out the other lectures. So thanks. Until later, until the next paper or the next discovery, or just the next time I feel like making one of these presentations. So bye.